The most important company in AI might be the one behind the seasoning in your kitchen, Ajinomoto. The name literally means the essence of taste. They commercialized MSG in 1909, and today every NVIDIA GPU, every AMD server processor, every custom AI chip Google and Amazon design, none of them can ship without a film this food company makes. A film about as thick as a human hair. It's called ABF, Ajinomoto Buildup Film, and one company controls more than 95% of the market. No qualified second source. 26 years and nobody has cracked it. When this film's supply chain seized up in 2021, GPU lead times stretched past 6 months. The AI boom, it turns out, runs through a seasoning company. This is Forgotten Monopolies, Episode 7. To see why a film matters this much, you need to see where it sits. A modern processor doesn't connect to a motherboard directly. The silicon die sits on a packaged substrate, a miniature, ultra-precise circuit board that fans out thousands of microscopic connections from the chip to the board underneath. In Episode 3 of this series, we covered the companies that build those substrates, Ibiden, AT&S, and their peers. But here's what we only hinted at back then. Every one of those substrate makers, on every advanced line they run, buys the same critical raw material from the same single supplier. The substrate is built up layer by layer. Copper wiring, then insulation, then copper again, sometimes more than 10 layers on each side. That insulation layer is ABF. Strip an AI accelerator package down to its skeleton, and you'll find more area of this film than of silicon itself. So today, 4 questions. Why did a food company end up owning this? Why did a film beat every alternative? Why has nobody copied it in 26 years? And what does AI do to the quiet business behind it? The answers explain how the deepest moats in semiconductors actually get built. Deep Dive 1. The Accident of Chemistry. Ajinomoto's core science has always been amino acids. That's what MSG is. And here's the part almost nobody connects. Amino acids happen to be excellent hardening agents for epoxy resins. In the 1970s, the company started basic research on applying its amino acid chemistry to epoxies and their composites. Decades of food chemistry had given them something money can't easily buy: deep institutional knowledge of how organic molecules behave, cure, and stay stable. By the early 90s, that research had become a niche product line: insulating inks for circuit boards. Useful, but small. The turning point came in 1996. A leading CPU maker, Intel, came knocking with a problem. Processors were getting faster, and their packages needed a new kind of substrate with much finer wiring, built up in layers. Liquid insulating inks couldn't do it. Coating them evenly across fine copper patterns was a nightmare, and yields collapsed as wiring shrank. Intel wanted the insulation in a totally different form, a solid, uniform film you could laminate on like a sticker. A researcher named Shigeo Nakamura led the effort. It took about 10 years of sustained R&D investment from the early 90s before the answer was ready. In 1998, the group consolidated its fine chemicals business into a subsidiary, Ajinomoto Fine Techno. In 1999, ABF went into production, and into the substrate of the Pentium era's flagship processors. The food company hadn't diversified into electronics. Its chemistry had simply been pointed at a different target. And because nobody else had 50 years of amino acid epoxy know-how, nobody else could follow the same path. Deep Dive 2. Why film beat everything? The insulation in a packaged substrate has to do 3 nearly contradictory jobs at once. It has to insulate cleanly at high signal frequencies, low dielectric loss. It has to expand at almost exactly the rate of silicon and copper when the chip heats up. Otherwise, connections crack. And it has to be drillable at micron scale, because every layer needs millions of tiny vias, vertical holes that carry signals between wiring layers. Standard circuit board materials fail the third test immediately. They're reinforced with woven fiberglass, and a laser can't drill a clean 5-micron hole through glass weave. ABF has no weave at all. It's a thermoset epoxy loaded with ceramic filler particles, engineered so a laser can ablate vias with surgical precision. Researchers have demonstrated vias down to 3 microns. Copper lines can be patterned below 10 microns, and because it ships as a solid film, 10 to 100 microns thick, on a carrier sheet, it laminates onto a patterned layer with perfect uniformity, then cures hard. No coating variation, no puddling, no thickness drift. That's what lets substrate makers stack 10 or more build-up layers per side and still get yield. Now scale that up to an AI accelerator. A data center GPU package is enormous. The substrate spans dozens of square centimeters, with more wiring layers than anything in a laptop. More area, more layers, more film. Every generation of AI silicon quietly multiplies the amount of ABF inside each package. The film isn't a commodity input. It's the enabling geometry of the whole package. Deep Dive 3. The moat and the stress test. Here's the uncomfortable truth for would-be competitors. The recipe is not the secret. You could analyze ABF in a lab tomorrow. What you can't reverse engineer is 26 years of process know-how. How to disperse filler particles with perfect consistency, how to hold flatness across a roll, how to keep behavior identical batch after batch. That knowledge lives in process parameters and equipment tuning, not in any patent you can read. Then there's the lock-in. A package substrate takes weeks to build, layer by layer. A flaw in any single insulation layer scraps the entire substrate and the expensive silicon schedule behind it. So no substrate maker risks an unproven film to save a few percent on material cost. The asymmetry is brutal. Tiny savings, catastrophic downside, and Ajinomoto plays offense too. The company runs what it calls a high-speed development cycle, co-developing the next generation of film years in advance, directly with both substrate makers and the chip designers above them. By the time a new chip generation arrives, the matching ABF grade is already qualified. Sekisui Chemical, the only nominal alternative, has held a few percent share at the low end for 2 decades without cracking a single high-performance grade. Then came the stress test. In 2020, COVID demand surged just as a fire knocked out a key Japanese materials plant. Substrate lead times blew past 24 weeks. Prices jumped as much as 40%. AMD had to triage which processors to build. Fortune ran a story about obscure substrate suppliers' shares rising 1,200%. And when the dust settled, the bottleneck was solved by substrate makers adding capacity, all of it consuming more ABF. The shortage tested the monopoly. The monopoly passed. Deep Dive 4. The AI Money Math. Now the numbers, and they are remarkable. In the fiscal year just reported, Ajinomoto's electronic materials business generated about 100 billion yen in sales, up 31%. That's only 6% of the company's revenue, but it threw off 54.6 billion yen in business profit, 30% of the entire company's profit. The margin on this segment now exceeds 50%. Seasoning and frozen foods run single-digit margins. The film business prints money at software-like rates, and the mix is shifting in exactly the right direction. In fiscal 2017, about 40% of ABF went into servers and networking. Today, it's 70%. The company projects up to 85% by 2030 because AI packages are the biggest, most layer-hungry substrates ever built. Morgan Stanley expects ABF substrate demand to outrun supply again, with a shortage forming around 2027 and the market compounding at roughly 16% a year through then. Ajinomoto's response: invest 25 billion yen by 2030 to lift film capacity by 50%, and in May 2026, it bought land for an additional plant targeting 2032. What about the glass substrate revolution you've heard about? Look closely at the architecture. Glass replaces the organic core in the middle of the package, not the build-up layers around it. The leading roadmaps are hybrids, a glass core with ABF build-up layers laminated on top, same as before. The disruption story, examined carefully, adds a new component while leaving the film monopoly exactly where it was. 2 to 3 times the cost and yields in the 70s and 80s% will keep glass niche for years anyway. Heads, Ajinomoto wins. Tails, Ajinomoto doesn't lose. The verdict. In the series finale, we scored 9 forgotten monopolies on 4 dimensions: pricing power, customer concentration, substitution risk, and CapEx insulation. Disco and KLA top the table at 19 out of 20. So where does the film company land? Pricing power, 5 out of 5. Margins above 50% in a materials business are not negotiated. They're imposed. Customer concentration, 4 out of 5. The film flows through several substrate makers, Ibiden, AT&S, Shinko, Unimicron, and underneath them, effectively every advanced chip company on Earth. No single customer can hurt it, but the substrate industry's own cycles can. Substitution risk, 5 out of 5. 26 years without a qualified competitor at the high end, and the glass transition strengthens rather than threatens it. CapEx insulation, 4 out of 5. A film plant costs billions of yen, not trillions. The entire 2030 expansion is 25 billion yen, roughly the price of a single EUV scanner line. 18 out of 20. That puts a seasoning company shoulder to shoulder with the sharpest monopolies in the semiconductor supply chain. And here's the structural lesson of this whole series. Distilled. The companies everyone watches, NVIDIA, TSMC, earn their position in public under constant attack. The monopolies nobody watches are materials businesses, where 50 years of chemistry know-how compounds silently, where qualification risk makes switching unthinkable, and where the customer's customer doesn't even know your name. And that produces the strangest valuation situation in this entire series. Ajinomoto trades as a food company, gets analyzed as a food company, and is benchmarked against soup and seasoning peers. Yet 30% of its profit is a semiconductor materials monopoly growing 25% a year with 50% margins. 6% of revenue, 30% of profit. The market files it under food. The numbers say something else entirely. Watch the numbers. If this changed how you look at the AI supply chain, subscribe. This channel exists to find the choke points the headlines skip. The Forgotten Monopolies playlist has the full map so far. The EDA duopoly, the wafer duopoly, the substrate makers, KLA's inspection monopoly, and the dicing duopoly behind every AI chip. ABF is the 7th, and the series isn't done. Next time, we go inside the monopoly hiding inside ASML's monopoly. Lasertec, the only company on Earth whose machines can inspect a blank EUV mask. Every EUV chip ever made passed through their field of view first. One company, one product line, 100% share. That story is next. The actual semiconductor industry view. See you there.